Now here comes something that you might find very useful and might come in very handy and be very important in later sections. We're going to find out in a later lesson how to change the limits of integration by changing the variables of integration here and here, but I wanted to show you that. So sketch the region represented by the integral. So in other words, I'm going to give you the integral, you're going to show me the region. Actually, I'm going to do it, but and then find another iterated integral in the opposite order. In other words, this one's x first, then y. We're going to find one that's y first, then x, and both yield the same value. Okay, so we can see that since our x limits are x going from y squared to 4, so that means x equals y squared is this piece of a parabola here. I mean, the parabola would keep going down here, but x is going from y squared to 4, and y is going from 0 to 2, so we stop y here. That's why we don't have the bottom part, and we stop y here at the upper part. So the x limits are y squared to 4, so here's 4, here's where x stops, out here at 4. So that pretty much is it. So we can see this describes our region perfectly. But we're not going to do it that way. We want to switch. We want to say, what if we looked at it as this is the top and this is the bottom? Then y would be going from 0 to square root of x, and x would be going from 0 to 4. What's going to give you grief is you got to remember the constants will also change, right? Your limits of integration for the last of the iterated integrals will change. So both of these yield 16/3, and really you should check that. You should check this solution, and you should check this solution, and see if, find out what this is, find out what this is, and so you should check that for each of those integrals you get 16/3. And I could make it part of this file, but I really hope you could work that out on your own.
That's pretty much it.
That's it.